Imagine being able to ask an AI to create a long video, like way longer than just a few seconds, you know, and give it commands like turn left or pick up that apple, and it all just flows smoothly and realistically.
That would be pretty awesome.
Yeah, it's like the future of filmmaking right in our hands. Well, the future might be closer than we think. We're diving into a research paper today that's making some serious progress in that area. And here's a really cool part. It's inspired by the way our brains learn.
I love when AI research takes cues from how we humans do things.
Yeah.
It often leads to some really innovative solutions. And in this case, it's all about tackling a big challenge in video generation, making sure things stay consistent over long sequences.
Yeah, because we've all seen those AI-generated videos where things just get weird after a while, right?
Exactly. Objects change color for no reason. The background suddenly shifts. Characters forget what they were doing. It's like the AI has a short-term memory issue.
It's like watching a movie where the editor dozed off.
Yeah.
Totally
Yeah.
breaks the immersion.
Right. And that all boils down to a lack of something we humans kind of take for granted. Episodic memory.
Episonic memory, so like our ability to remember specific events and experiences.
Exactly. It's what allows us to recall details and create a coherent narrative of our lives. And it's what's missing in a lot of AI models. They're great at learning general rules, like procedural memory, like how things work in a general sense, like the laws of physics or the basic principles of animation.
So they're like the student who aces the textbook but can't remember what they had for breakfast?
Pretty much. They struggle to hold on to those specific details over time, which is why things get messy in longer AI-generated videos.
So this paper is about giving AIs a better memory, like a memory upgrade.
You got it. The paper is called SlowFast-VGen, Slow Fast Learning for Action-Driven Long Video Generation. And it introduces a new model that takes inspiration from our brains.
Right. You mentioned that earlier. We have that slow learning system, like our neocortex, which handles general knowledge, and the fast system, like our hippocampus, which deals with those specific memories.
Exactly. And this paper, authored by Yining Hong, Bade Liu, Maxine Wu from UCLA, and a team from Microsoft Research, aims to give AIs that same kind of dual learning power.
Okay, so how do they actually do that? What's the secret sauce of SlowFast-VGen?
Well, the key is in the name. Slow Fast Learning. It's a two-speed approach that mirrors how our brains work. The first stage is what they call slow learning, and it involves using something called a masked conditional video diffusion model.
Okay, now those are some words that definitely need some unpacking. Masked conditional video diffusion model. I'm sure our listeners are curious about what all that means.
I don't blame them. It sounds pretty intimidating, but the concept itself is actually quite intuitive. Think of it like this. Imagine you have a photograph that's been damaged. Maybe it's water-stained or ripped in places. A diffusion model is kind of like a magical photo restoration tool.
Oh, okay, I'm intrigued.
It takes that damaged image and gradually removes the noise and imperfections step by step until you're left with a clear, restored image.
So it's like taking a blurry, messed up picture and slowly refining it until the original image emerges from underneath.
I like that analogy. Exactly. Now, in the context of video generation, this diffusion model is trained on a massive data set of over 200,000 videos with actions annotated. So all sorts of activities are labeled and categorized in these videos.
Oh, 200,000 videos?
Yeah.
That's a lot of data. So we're talking like cat videos and fail compilations?
Well, actually, this dataset's pretty diverse. It covers things like Minecraft gameplay, real-life cooking scenarios from the Epic Kitchens dataset, robot tasks, even human driving.
Wow, so it's like giving the AI a crash course in all sorts of real-world actions and scenarios.
Exactly. By training on this massive and diverse dataset, the diffusion model learns to associate specific actions with the corresponding visual patterns. It's like learning the vocabulary of movement.
So if it sees someone reaching for a cup, it learns what that action typically looks like.
Precisely. And this forms the basis of the AI's slow learning. It gradually builds up this general knowledge of how things move and interact in the world, like learning the basic rules of the game.
Okay, that makes sense. So the slow learning part is all about building a foundation of general knowledge. But what about the fast learning part? How does SlowFast-VGen handle those specific details that trip up other models?
That's where things get really interesting. They introduce a temporary module called Tempora, and it acts like the AI's own personal hippocampus.
Wait, so if the diffusion model is like learning physics and basic behavior, Tempora is like taking notes on the specifics of what's happening in this particular video.
Exactly. Tempora kicks in during the video generation process. It's constantly watching what's unfolding and storing those specific details in its memory. So for example, if the AI generates a scene where a character picks up a green cup and puts it on a white table, Tempora makes a note of that green cup, white table. It's like a mental checklist.
So it's like the AI is building its own little mental scrapbook of the video's history.
Exactly. And here's the key. As the video goes on and gets more complex, Tempora acts as a reference point to prevent those inconsistencies. When the AI needs to generate a new frame, it can check its Tempora memory, make sure that the cup is still green, the table is still white, and everything stays consistent with what happened before.
So Tempora is like the continuity supervisor on a film set, making sure everything looks the way it should.
That's a great analogy, and this is what allows SlowFastVGen to create those longer, more coherent videos. It's combining general knowledge with specific memories, just like we do.
It's amazing how they're mirroring the way our own brains work.
Yeah.
And it makes you wonder, if we can create AIs that learn and remember like we do, what are the possibilities?
The possibilities are pretty mind-blowing. I mean, think about it. AI that can plan ahead, remember past events? It could revolutionize all sorts of fields.
Yeah, like what? Give me some examples.
Okay, well, the researchers actually put SlowFast-VGen to the test with some pretty challenging tasks. One involved robot manipulation, where the AI had to figure out how to move these cubes around and then put them back in their original spots.
Oh, like a virtual Rubik's Cube kind of thing?
Sort of, but with more emphasis on remembering the sequence of moves. And then they also tested it with a Minecraft navigation task, where the AI had to retrace a path through this virtual world.
Okay, so both of those tasks really require the AI to remember specific details and use that memory to make decisions.
Right, exactly. It's not just about generating a cool-looking video. It's about understanding the sequence of actions, remembering what happened, and using that information to plan ahead.
Got it. So how did SlowFast-VGen do? Was it able to handle those challenges?
It totally crushed it. In both tasks, SlowFast-VGen outperformed other AI models by a significant margin.
Like by how much? Give me some numbers.
Well, one metric they use is called the FVD score, which stands for Frechette Video Distance. It basically measures how realistic and high quality a generated video is, and lower scores are better.
Okay, so the lower the score, the better the video, basically.
Right. And SlowFast-VGen achieved an FVD score of 514, which is way lower than the 782 score of a previous top-performing model.
Okay. But for those of us who aren't AI experts, what does that actually mean? Like, what makes a lower FED score better?
So the FED score basically looks at how similar the features in the AI-generated video are to the features in real-world videos. It's a way of measuring how well the AI captures those visual patterns and movements that we see in real life.
So it's not just about whether the video looks good to us humans. It's about whether it actually replicates the way real-world videos are structured on a deeper level.
Exactly. And in the case of SlowFast-VGen, that lower FED score translates into videos that are not only more realistic, but also more consistent over time, which is really important for longer videos.
Yeah, because if things are constantly changing or jumping around, it breaks the illusion.
Exactly. And they actually measured this consistency in a couple of ways. First, they looked at the number of scene cuts.
Scene cuts, like when the video abruptly jumps to a different location?
Yeah, like if you're watching a movie and the scene suddenly changes without any transition. That's a scene cut, and it can be really jarring.
Yeah, it takes you out of the moment.
Right, and SlowFast-VGen had way fewer scene cuts than other models, so its videos were much smoother and more natural. On average, it only had 0.37 scene cuts per video compared to 0.89 for another leading model.
That's a pretty big difference. It's like the difference between watching a professionally edited film and a home movie with a bunch of jump cuts.
Exactly. And beyond just the number of cuts, they also looked at what they call scene revisit consistency.
Scene revisit consistency. Okay, I think I'm going to need an explanation on that one.
So imagine you're exploring a virtual world, like in a video game. You walk through a forest, then go into a cave, and then come back out to the forest. Ideally, that forest should still look the same when you return, right?
Yeah, of course. If the trees suddenly changed color or something, it would be super weird.
Exactly. Scene revisit consistency measures how well the AI remembers what a scene looked like, even after the camera has moved away and come back.
So it's like testing the AI's spatial memory.
Exactly. And SlowFast-VGen was amazing at this. It could accurately remember the details of a location, even after generating a bunch of other scenes in between, which is really impressive.
Yeah, it's like having a photographic memory for virtual environments.
Right. And it all comes down to that dual-speed learning system and the way SlowFast-VGen mimics how our brains work. By combining that general knowledge with specific memories, it's able to create videos that are both realistic and consistent over time.
It's fascinating how they're drawing inspiration from human cognition. And it's making me think about the bigger picture here. If we can create AIs that can learn and remember like we do, What kind of impact could that have on our world?
Oh man, the possibilities are endless. Well, for starters, imagine virtual worlds and games that are truly immersive and responsive.
Okay, so like instead of those NPCs that just repeat the same lines over and over.
Right, exactly. You'd have AI characters that actually remember your past interactions, learn from your choices, and build relationships with you that evolve over time. It would be like living in a constantly unfolding story.
Wow, that would be incredible. Like
Yeah,
your actions actually have consequences.
exactly. And it goes beyond just entertainment. Think about education and training. Imagine learning history by interacting with AI-powered historical figures who can answer your questions and share their experiences in a really dynamic way.
Oh, that would make history class so much more engaging.
Right. Or think about training simulations for like surgeons or pilots where the AI can create these super realistic scenarios that adapt to the learner's actions and provide personalized feedback.
So it's like having a personalized tutor who can create custom learning experiences tailored to your needs.
Exactly. And this is just scratching the surface. The researchers suggest that future work could focus on enhancing the AI's ability to handle even more complex scenarios and create videos that are not just realistic, but also creative and maybe even artistic.
Oh, so we could see AI directors creating entire films.
Potentially. Or maybe even generating personalized news segments that cater to your specific interests.
Wow, the possibilities are pretty mind-blowing.
They really are. But it's important to remember that this technology is still in its early stages. There's a lot more work to be done.
Yeah. What kind of challenges are we talking about?
Well, one of the big ones is scalability. SlowFast-VGen was trained on a pretty specific data set. But to create AI systems that can generate videos across a wide range of domains, we need to develop models that can learn from even more massive and diverse data sets.
So it's like teaching a child. The more experiences they have, the better they understand the world.
Exactly. And another challenge is controllability. It's great to have AI that can generate creative content, but we also need to make sure we can guide and control their output. We need tools that allow users to specify their goals and preferences.
Right, so it's not just about letting the AI run wild. We need to make sure it's aligned with our intentions.
Exactly. And of course, we can't forget about ethics. As AI becomes more powerful and capable of creating realistic and compelling content, we need to be super careful about how it's used.
Yeah, we've already seen how AI can be used to create deepfakes and spread misinformation. So it's important that we address these ethical concerns as the technology develops.
Absolutely. We need to have open and honest conversations about the potential risks and benefits of this technology and involve experts from different fields to make sure it's used responsibly.
It sounds like we're on the verge of a whole new era of AI, one where machines can not only process information but also understand, remember, and even create like we do. It's both exciting and a little bit intimidating.
I agree. It's a time of incredible opportunity, but also a time for careful consideration and responsible development.
Well, this has been an absolutely fascinating deep dive.
Hmm.
It's amazing to see how researchers are pushing the boundaries of AI and taking inspiration from the way we humans think and learn.
It's been a pleasure sharing these insights with you.
And to all our listeners out there, if you're as intrigued by this research as we are, we encourage you to check out the paper yourself. We'll include a link in the show notes. And as always, keep exploring, keep learning, and keep asking those big questions. Until next time on The Deep Dive.